So this is a required practical, and what he's done is he's changed the angle of incidence and he's measured the angle of refraction. So when we have a ray of light going into a glass block, it's going to refract towards the normal. So what that means is that it would have gone straight like that, but because of the glass block, it's gone towards normal. This is the normal here, the dotted line. And it's going to refract again on the way out, and then it's going to refract away from the normal. You can see how this is now away from it. I'm just going to move this. Can I move this down like that? There you go, that's a bit better. Now, one of the things that you need to identify in this, and lots of these kind of method questions, is to notice what's going to be difficult about actually measuring all of this. So how would we go about changing the angle? How would we go about measuring this angle here? If there's a glass block in the way, you can't very easily get a protractor over the top of it and measure it accurately. So what you do is you place the glass block there, and then you draw around it. So the way I'm going to do it here is I'm going to make a copy of it, put that over there. I'm going to make that one like that. And I'm going to make this into a dotted line. So we'll say that's. You don't need to actually draw a dotted line there, of course, but now you've drawn that, and of course the rays of light won't look the way that they're looking right now. But when you place it back on, and you take your first experiment at 10 degrees, then you'll see the ray going acting in the way it's acting there, and then this is where you're going to get a pen and make a little mark there, and another little mark maybe here, okay, and then make a mark there where you enter the glass block, and maybe another mark over here. So then when you remove the glass block, then you can join up, and you can turn the light source off then, and you can just join the dots with a ruler to draw straight lines. And then you can measure the angle using of that line with a protractor. That's the main thing that's going to be difficult about it. You can't use a protractor while the glass block is there, and then when you remove the glass block, the rays of light aren't the way that they were. So that's the tricky bit. You also need to make sure that you draw a normal. So this is the normal here, and so is that dotted line there. And that you draw a normal at the point at which the light is going into the glass block and at 90 degrees to the glass block. So make sure it's at exactly the point that the ray of light is going into the glass block and at 90 degrees to the glass block. Same over here. Okay. Now he's only actually interested in these two angles because it's, as it says, it's just going as it goes into the glass block. So if I do, I'm going to get a screenshot now of the mark scheme. If we zoom in on this, place a glass block on a piece of paper, draw around the glass block, use the ray box to shine a ray of light through, mark the ray of light entering the glass block, mark the ray of light emerging from the glass block, join the points together to show the path of the complete ray. These are all things that I said, right? Use a protractor to measure the angle of incidence, use a protractor to measure the angle of refraction, and then make sure, of course, to make a note of saying repeat this process for 10, 20, all the way up to 80 degrees. It's not got anything in here about any difficulty with changing the angle of incidence. So what some people do is they keep the ray box still and they just rotate the glass block. That's up to you, really. If you did the downside to that, well, let me think. Yeah, you could do that, but I would rotate the piece of paper as well. and so and then you can keep the ray box off the piece of paper, and you rotate the glass block with the piece of paper. So as the angle is 10 degrees, then 20 degrees. The other thing I would do, actually, this makes the whole job a lot faster. Is you choose the point at which the ray is going to go into the glass block, and then from here you pre-select points of 10, 20, 30, 40, 50, 60, 70, 80 degrees, and then you shine down those lights. So you've already, because you know what you're choosing the instant angle already, and so so you just basically, let's say that one, you just choose the next angle and the next angle like that, and then when you take, so then out here you could just do a load of them all in one go and just mark the point there, and then just write that as like 10 degrees, do another point over here, mark that as 20 degrees, and so on, and then remove the glass block and join them all up and label all the lines and measure all the lines all in one go. So this one, so you'd get 10 degrees there, and anyway, I hope that makes sense. So that's basically how to do it. Now, when you're trying to mark these questions for yourself, the most important bit is going to be the indicative content. Technically, this is the bit at the top that you use to mark it, but if your explanation is clear and flows, and it contains most of these indicative content, then you're bound to get 5 or 6, probably 6 marks. You can use this as well, but mainly stick to following the indicative content. It's a lot easier. Okay.